2024 Paper 2, Question 15. It's to do with arcs and sectors. So this diagram shows a sector of a circle with the centre C, and you know the radius and you know the arc length. You have to calculate the area of the sector. So the first thing we want to do is we'll pause the video if you want to and have an attempt at it, but I'm going to continue. So the arc length an arc is simply a portion of the circumference or the perimeter of a circle. So this AB is a portion. So the formula for the circumference of a full circle is 2 pi multiplied by the radius. And then you want to multiply this by the proportion. The proportion is equal to this angle divided by 360. So you're going to then have angle ACB divided by 360 degrees. And we're going to substitute into this. So we have the arc length is 15 centimeters. 2 equals 2 pi multiplied by the radius is 12. And multiplied by angle ACB over 360. Then we can rearrange all of this, and if we multiply the whole thing by 360, there's a lot of rearranging happening in this question. 15 times 360 equals 2 pi times 1224 pi multiplied by the angle of ACB. Dividing the whole thing by 24 pi gives us that the angle is 15 times 360 degrees divided by 24 pi. And we have to find the area of the sector. So to do that, we'll look at the area of a sector formula. So that's again a portion of the area of a full circle. So that is, well, the circle is pi r squared. And again, you take the portion ACB over 360. Let's substitute in. We get pi multiplied by 12 squared multiplied by plug all of this in, we get 15 times 360 divided by 24 pi, and then all of this has to be divided by 360. This gets complicated, but if we treat this whole thing as the numerator and this is the denominator, put the denominator in green, let's cancel a 360 out. So what we're going to do is divide the numerator and the denominator by 360. We then cancel that out. But if you want to divide the numerator, which is again another fraction, by 360, we then cancel this out, and we are left with pi times 12 squared times 15 divided by 24 pi. And you want to plug this into the calculator. We get 90. And our units are centimetres squared because it's an area. And that's the answer. Let's have a look at how this was marked in the exam. Quite a difficult question. So the first part would be for the strategy for finding the angle. So this line would have been a mark. The next part would be for knowing how to get the area of the sector, and the third mark would be for getting the final answer. You wouldn't get the second mark if you only found the angle at the centre. You could evaluate this at this point, this, and get a value for ACB, but you don't have to actually do this. You can just plug that into the formula for the area. It does not matter if you do that method or you find a value. If you plug this into the calculator and get a value, then plug that in. But I think they're both difficult methods, but I think that the way I've done it is a bit easier. And it's less prone to losing marks by rounding issues. And a few commonly observed responses were issues with rearranging the equation, and people mixing up the formula for the arcs and sectors. So that also cost people marks if they used the arc formula when they wanted to find the area of a sector, or vice versa. And issues with the algebra of manipulating the equation, that also caused issues. So I'll leave this here, and that's what we did. But I hope you found this useful. Best of luck with the studying. Thanks for watching.